Good afternoon, everyone. Today's lesson will be on transformation. Transformation. So we're still manipulating the graph. So transformation. And as usual, we like to reiterate the importance of prior knowledge. Prior knowledge. So consider the concept. Cartesian plane. Alright? The horizontal and the vertical number line which intersects perpendicular with a scale of 1 to 1, 1 unit representing 1 centimeter, which for the most part we're going to work with this type of scale in transformation. Alright, so here we have the Cartesian plane. Just to recall, coordinates, a set of ordered pair, an x value and a y value. And remember, we always name the x value before the y value, hence the concept ordered pair. But together we call both of them coordinates, and together they make a point. For example, the point 2, 1. So here we find 2 on the x-axis, and using the line that is located on, move to 1, because it's positive 1 vertically. So the point 2, 1 will be located here. So a point really is a position in space. So we use the coordinates x and y value together call a point, and a point is a position in space. Okay, let's consider some more coordinates. -3 on the x-axis, 1 on the y-axis for point A. So -3s are to your left of the origin horizontally and moving to 1. So point A will be located right there. Point B, -6, +1. So -6 on horizontal, we move across, we go across to find the x value. Then we go up or down, but what we want +1, so positive is up. So here we have another point, position in space. Point C, -6, 5. So we find -6 again on the horizontal axis, which is the x-axis, and we want +5, so we go up to find +5. And there we have another point. Now, transformation. As usual, I like to reiterate, there's no one way of doing a mathematical procedure or showing a mathematical procedure, as long as you're showing the how and why in your calculations. Okay, now let's define the concept transformation. You might have heard about the concept in real life and watching movies. Transformers, you realize robots are transforming, taking different shape and form, turning from motor vehicles to tall, humongous sized robots. Now in mathematics, there are more than one definition we can use or explanation. There is no one explanation. Ensure that you understand it in your own way. Transformation can be or is said to be a rule that moves every point or vertex in a plane figure. Transformation is a rule that moves every point or vertex in a plane figure. For instance, these 3 points to the left of the second quadrant, if you observe, if I join these 2 points, it will create a right angle triangle. In some earlier class, I told you that so graphs are not only straight line or curved line, but shapes can be formed on the Cartesian plane. We can call them graphs also. Okay, so the definition is saying transformation is a rule that moves every point, so these points can be moved. Okay, point or vertex, because if I join these points I could create a triangle like this, and the vertex will also, which is a corner, which we learned from measurement, still represents the points. So what they are saying, if we move each point in the same direction, this shape will automatically move. So transformation is a rule that moves every point. These points, if we connect them, create this shape, would create a shape like that. Or vertex, so the points will form the vertex, the corners, in a plane figure. Now this is called a plane figure because it's on the Cartesian plane, and it's a figure. Figure is a shape. So if all the points move that way, the shape can move that way. It can move this way. It can move vertically, different ways. Okay, so that's one definition. A rule that moves every point or vertex in a plane figure. So a plane figure is just a shape on the Cartesian plane. Another explanation or school of thought: transformation is the change in size or position of a point or shape. So you'll always hear point because automatically when the points move, all the points move, the shape will automatically move. All right, so a change in size. So what they are saying, that the size of the shape can increase in size, which is enlarge, or it can decrease in size also. Okay, and some of these definitions will bring out different types of transformation. So that's another definition, the change in size or position, because the position, it can go vertically up, down, horizontally, backwards, forwards, stuff like that. Another definition, transformation describes the relation between any point and its image. So throughout the lesson, you always hear them talk about, or in question, you hear them talk about object and image. The original point or the original shape is the object. So this will be called object. And when we transform it later on, you'll see why we call it the pre-image, a replica of this object. Right? So there's another version of this object will be created. So the original will be called the object or pre-image, before the image, and then the replica or the one that's created of it is called the image. Another definition, transformation describes the relation between any point and its image. Okay, so transformation. So here we have three different definitions that I gave you. So that's a brief synopsis of the different types of transformation. One type of transformation is called translation. So one type of transformation that can take place is called translation. Another type is called reflection. As you hear these words, try to recall from own experience in real life what you think these are talking about. Another type that we'll focus on is called rotation. And the final one that we'll focus on is called enlargement. So these are the ones that we'll be focusing on throughout this lesson on transformation. The transformation, change in size, position of a point or shape, plane figure. And the types of transformation that we'll be focusing on, there are other types, but the one that we'll be focusing on is translation, reflection, rotation, and enlargement. Okay, so the transformation that we'll be focusing on today is translation. Again, the transformation that we'll be focusing on today is translation. Definition: translation is a transformation that displaces, move a figure on the Cartesian plane without turning it. So what we're going to do today, when we translate a plane figure on the Cartesian plane, it's going to slide, displace, move into different positions without turning, meaning it won't turn. Okay, so translation is a transformation that displace or slide. Displace means move the figure on the Cartesian plane without turning it. Okay, now translation is denoted by the symbol T. So all forms of translation have notation. So mathematics is important to know your notation. We're talking about translation, then you normally use the notation T. Okay, because sometimes they won't use words, they will use symbols. So the notation T represents translation. Now, translation are described using vectors. Vectors. A vector is a quantity that has magnitude and direction. A vector is a value, amount that has magnitude and direction. So in this case, it's represented like this when you're talking about translation. And sometimes you might hear them say column vectors. If you did a lesson at school, in matrices are vectors already. Translation T represented by in vector form, column vector. Okay, so basically we say it's a quantity that has magnitude and direction. So most time you're given something like this, for example 5, 7, which is in the coordinate form. But to write it in vector form, we represent it as translation using the vector 5, so the coordinate is rewritten like this. The x value and the y value is rewritten when you're using translation. So this is a vector. So this now is written like an array, 2 rows, 1 column, 2 rows, 1 column, and this is the coordinate basis. So it tells that the first value represents the x, second value represents the y, and this is how they represent vectors as column vector. Now the vectors tells us the direction that we're going to translate our point, which automatically will move the plane figure. What this vector is saying, that we're going to move the point positive, we have to observe if it's negative or positive, 5 units horizontally from where it's located in the right. Once it's positive, we move to the right, and positive 7 here, we're going to move the point 7 units upwards, positive side of the y-axis. So what am I saying? If I want to move this point 2, 1 using this vector translation 5, 7, this is saying that I'll move the point 5 units to the right, 1, 2, 3, 4, 5, and then 7 units up, 1, 2, 3, 4, 5, 6, 7. So this is where the point will translate to from here using the vectors 5, 7. So what I'm showing here is method 1, one method of moving the points. Okay, so this would be one method of moving or translating points or objects on the Cartesian plane. Alright, let's look at this translation. Translation T, given the vector -4, 6. So what this is saying that, see, we're focusing on this same point. This is saying that if I want to translate this point, using this vector, I'd move this point 4 units horizontally. Because it's negative, we go left, and then 6 units positive upwards. So let's demonstrate that. 1 unit. You realize where we start, we don't start on the point. From here to here is just the first unit. So 1, 2, 3, 4 units to the left, and positive 6, that's mean we're going upwards now. 1, 2, 3, 4, 5, 6. So the point will end up here. Okay, so we are doing method 1 of how to move the points when we're translating. This is one method. Let's go again. Suppose you are given this vector. Translate the point 2, 1 using the vector 7, -9. What this is saying that I'm going to move 7 units to my right and 9 units downwards. So let's go. 1, 2, 3, 4, 5, 6, 7 units to my right because it's positive, and then -9 mean I'm going down from where I found the 7 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this point will end up down here by translation using the vector. So this is one method of moving all the points. So for example, these 3 points here, if I create this triangle right here, on point A, B, C. If you are given the question to translate each point using this vector or this vector, we will just simply observe each point. You can use that. Let's use the point. We're going to use the vector 5, 6. So what this is saying that I'm going to move each point 5 units, guys, positive 5. Each of them going to move 5 units to the right, and because it's positive 6, each going to move 6 units upwards. So let's go. So moving point A, and this is method 1 again. 1, 2, 3, 4, 5. Then 6 units upward. 1, 2, 3, 4, 5, 6. So A would now be here. Moving point C using the same vector. 1, 2, 3, 4, 5. And 6 units upward. 1, 2, 3, 4, 5, 6. So point C will be there now. Moving point B. 1, 2, 3, 4, 5. Then 6 units upward. 1, 2, 3, 4, 5, 6. Here we see our new shape is being translated. So this is method 1. We could use the vector to just move each point individually, and now we have our new translated shape. So the shape has slide from here to here using the vector 5, 6. So this is method 1 of finding it. Now this object, this is the object or pre-image, but this new shape now is called image, and we normally use a symbol over each letters, which is called prime. So A is mapped onto A prime, a simple stroke over it, C prime, B prime. Okay, let's look at an example. Draw the triangle with points A 2, 1, B 4, 1, C 2, 5. Hence translate using vectors R equal 3, 4 and 2 vector m equal 2, negative 8. So we're going to focus on just one of them. All right. So first of all, it said draw the triangles. So this is a graph we're going to create here. So using the points, so 2, 1 on the Cartesian plane. Okay. So 2, positive 2. So we find positive 2, 1. Next point, 4, 1. So we find positive 4 on the x-axis and 1. Point C, 2, 5. So we find 2 on the x-axis, and positive 5 will be up here. And remember, student, the question tells us what we want. So sometimes it may be a trapezium, maybe a rectangle. It said draw the triangle. So you should know that it's supposed to be create a triangle. Okay. All right. And remember to label your points. It's important to label your points. Okay. So point A is 2, 1. Point B is 4, 3, and point C. Now we have just created our object. Now we're going to translate it, we're going to slide it, we're going to displace it, move it without turning it using vectors. So we're using this vector. So we're working number 1. The vector we're using is 3, 4. Now we said method 1, we'll show you how we could do that with method 1. So given the vector, this is saying that we could move, since it's positive 3, each point will move 3 units to your right. And then positive 4, 4 units up. So method 1, you could just simply like this, starting moving point A, counting 3 spaces to your right. 1, 2, 3, then 1, 2, 3, 4. So A will drop here. Moving point B using the same vector, moving 3 spaces, 1, 2, 3, 1, 2, 3, 4, and so on. But what we're going to do now, we're going to use, I want to practice use both methods. So you can move it using the vector by just counting using the vector that's given. So look if it's negative or positive. You move to your left, it's negative, it's on the x value, and downwards if it's negative on the y value, and vice versa, opposite if it's positive for x and y. Now method 2, sometimes I prefer, is using the formula. So we could use just count the spaces, the units on the Cartesian plane, or we can use a formula. Vector plus object equal the image, because we are trying to create the image. So V plus O, vector plus object equal the image. Vector plus object equal the image. So the vector, we are doing number 1, so the vector here is 3, 4. Put it in bracket. Plus, following the formula, what's the object? The object points, these are the object's points. So the first point for A is, so we're going to write the coordinates in vector form. So the x comes first, the y comes below. For B, coordinates for B, we rewrite it in column vector form, just like what the vector is. 4, so x always go at the top, 1 at the bottom. And for C, 2, 5. Put all of them in bracket. So this is the vector, plus we're adding with the object points. Basically, translation, all the points going to move with automatically the object. Equal, we're going to get the points, the coordinates for the image. So for A, what will we get for A? What will we get for B? What will we get for C? So let's go. 3 plus 2, 5. 4 plus 1, 5. 3, for B now, vector plus the object, 3 plus 4, 7. 4 plus 1, 5. So we're getting a point for B. So moving on to C now. So adding the vector plus the object, 3 plus 2, 5. 4 plus 5, 9. So now we have just received our new coordinates, which is our image. So A will be coordinates for A prime. So this is A. So this is A prime because now the image would be 5, 5. For B prime, the new point would be 7, 5. And for C prime, how we use prime to represent the image point, would be 5, 9. So this is another method of finding the points to create the new object. So we can just count the space, or we can use this formula, vector plus object. So let's plot our point now. Since as we have our point 5, 5. So positive 5 to 5. And that's our A prime. B prime now, what is translated from B, 7, 5, 7, 5. And this is our B prime. And our C prime is 5, 9. C prime. And here we have translated our shape. And this is our image have just been translated here from our object. So here you have two methods. So this is the object, and most times students are instructed to write your object, because this is the original shape, and this is your image. So there are two methods you can use just by counting the unit space using the translation vector, or we can use this method using the formula, which has vector plus object equal image. And it's very useful because later on you can, because it's algebra, you can transpose. They might give you the reverse, give you the object and the image, and ask to find the vector.